Hello again, it's the Math Dog. In this video, I'm going to go over the classification of quadrilaterals. I guess I call this grade 7. I guess it could be anywhere from 5th grade up to high school, but I'll call it grade 7. This video is not to be shared or reproduced without the written consent of the creator. That's myself, the Math Dog. So before we talk about quadrilaterals, we're going to talk about polygons. So a polygon, we'll start with all these figures below here are polygons. They all have sides they have line segments for sides. This star, these are all line segments. This triangle, those are line segments. They all are connected. It's an enclosed figure. This is a triangle. Again, this arrow is a polygon. Those are all line segments. This is a rectangle. This is a parallelogram. Those are just some examples of polygons. So polygons are two-dimensional figures, which means they can be put on like a flat surface. They have line segments for sides. We just talked about that. And all these segments intersect at vertices. So for example, in this rectangle, there's 4 vertices there. Each vertex connects exactly 2 line segments. Okay, so here, this line segment here, this line segment here, at that vertex, there's only 2 line segments going into it. In this is actually a hexagon, 6-sided polygon. Notice that these 2 line segments here and here, only 2 of them intersected any one vertex. That's true for all these figures. Here's a vertex, there's 2 line segments. Here's a vertex right here, 2 line segments. That's true for all these figures. So that's a general informal definition of a polygon. So then these figures are not polygons. Here, notice this is not enclosed, but by our definition, here's a vertex, but you only have 1 line segment intersecting with it or coming into it. You need 2. Okay, so that's why this is not a polygon. So just visually you can see it's not enclosed, but by using our definition that each vertex has to have 2 line segments intersecting or coming into it, that tells you this is not a polygon. This is not a polygon because that is not a line segment, that is a curve. So it's not a part of a straight line. And in this one right here, you have 4 line segments coming into one vertex, so that is not a polygon. Now, if you could call each of these a triangle if you separated the figures, but this figure by itself alone is not a polygon. Okay, so some types of polygons. The smallest number of sides on a polygon is a triangle. Also, we could call it a threegon. 4 sides is what we're going to be looking at here in a few minutes here. The 4gon is called a quadrilateral. A 5gon, 5 sides, is called a pentagon. A 6gon is called a hexagon, etc., etc. Now, naming polygons. So we can put a letter, associate each vertex with a letter. This is a triangle. So some names for a triangle, we'll go over this in just a second. So naming polygons, you start at one vertex and go around to all the other vertices. Vertices are plural of vertex. You can go either clockwise or counterclockwise. So there's actually a bunch of names for this triangle. One is triangle ABC, but you could reverse that. Starting with A, you could call it triangle CBA. So that's the 2 ways if I start at vertex A. If I start at vertex B, so by the way, also, clockwise is rotating this way, CW for clockwise. Counterclockwise is rotating this way, CCW. So that's the way a clock runs, clockwise. Okay. So now if I start at B, I could go clockwise, calling it BCA, triangle BCA. And then I could go backwards, counterclockwise, call it triangle BAC. So then I could start at vertex C. If I go clockwise, that's triangle CAB. go counterclockwise as triangle CBA. So actually, this is not really what I wanted here. I want to start at vertex A, so that's let's get this cleaned up. So I went ABC, so I should have gone AC, triangle ACB when I went counterclockwise here. So there's 6 ways I could name this. They all are correct, but the thing is, you must go around in the order that you see the vertices. So for example, this would not be a correct name. Well, in the case of a triangle, there's no way you can skip a vertex. So actually, these are the 6 ways you can do it, and you really can't do it wrong with a triangle. But now with a quadrilateral, you could. So we'll look at a quadrilateral, the different names here. So let's say we start at R. So that would be, I'll just write quad to abbreviate. Going clockwise, that's quad RSTU, RSTU. If I went counterclockwise, that would be RUTS, quad RUTS. Let's write quad there. So quad RUTS. Okay, so if I started at S, I could call it quadrilateral going clockwise RTUR. I'm sorry, STUR. So if I went counterclockwise starting at S, I call it S quad SRUT. So if I started at U as my starting point, I could call it going clockwise quad URST. Or I could go counterclockwise UTSR. So then starting at vertex T, I could call it going clockwise quad TSRU. And going counterclockwise. So did I do that right? Actually, I went, that was counterclockwise. I want to go the other way first. So I want to go clockwise first. So that's quad TURS. And then going counterclockwise, that would be TSRU. There's actually 8 different ways using those 4 vertices that I could name this, and they're correct. So here's one that's not correct. If I went R, T, U, S, I'm naming the vertices out of order. You must go with consecutive vertices. That would be R, T, U, S. That's not correct. You must, when you start at a vertex, you must follow it around to consecutive vertices, either counterclockwise or clockwise. Okay, let's look at some special types of quadrilaterals before we try to organize them in some kind of hierarchy or classification. In general, a quadrilateral is a 4-sided polygon. So some special quadrilaterals are the rectangle. So characteristics of a rectangle are there are 4 right angles. These represent right angles. And opposite sides are congruent. Congruent, we use this symbol often, but congruent means same shape and size. In this case, these segments are the same length, so they're congruent. So these 2 are congruent, and then these 2 are congruent. So opposite sides are congruent. Okay, so then we have the square. Notice the square is a rectangle, but you actually have 2 pairs of opposite sides that are congruent. You have 4 right angles. All 4 sides are congruent. That's a defining characteristic of a square. Notice all squares are rectangles, but not all rectangles are squares. Then we have the rhombus. The characteristics of a rhombus are all 4 sides are equal. Okay. It turns out that opposite sides are in fact congruent as well. So we'll keep that in mind in the future. It also turns out these opposite sides are parallel. but the defining characteristic of a rhombus is there's 4 equal sides. But it turns out, again, these opposite sides, it's beyond us at this point to be able to determine that. We need to know about some things about angles before we can show that. So we have the parallelogram. Parallelogram is a quadrilateral, has 4 sides. Okay, opposite sides are parallel. So these 2 sides are parallel. Parallel means they never intersect. They're like railroad tracks. And these 2 opposite sides are parallel. It also turns out opposite sides are congruent. So let's go back to the rhombus for a moment. So while not the defining characteristic of a rhombus, the defining characteristic is simply it's a quadrilateral with 4 congruent sides. But it turns out these opposite sides are parallel. So that means actually a rhombus is also a parallelogram, which we'll talk about shortly when we do the hierarchy chart. It also turns out opposite sides are congruent. Not the defining characteristic, but it is a property. So lastly, we have the trapezoid. No, we have 2 more figures, not just the trapezoid. So one pair of opposite sides are parallel in a trapezoid. So notice this rectangle here, if we put 4 angles there, all rectangles actually are trapezoids, because it turns out rectangles also have opposite sides are parallel. That's not a defining characteristic, but it could be proven. Not with what we know at this time. And this is an isosceles, called an isosceles trapezoid, because these 2 segments here are congruent, and you have you have you have 2 sides here that are parallel. It's also isosceles here because these what we call base angles here, are congruent. So again, a trapezoid is simply, by definition, 1 pair of opposite sides are parallel. Therefore, actually, again, all parallelograms or trapezoids, they have 2 pairs of opposite sides, but a trapezoid is a more general classification. It requires just 1 pair of parallel sides. And finally, we have the kite. Okay, the kite is defined such that 2 pairs of consecutive sides, like this side and this side, are congruent. And here's another pair of consecutive sides that are congruent. Okay, now let's take a look at a hierarchy chart for polygons, and then more specifically we drill down on quadrilaterals. So we're going to start with polygons. So polygons are, again, figures such that at each vertex exactly 2 line segments intersect, and all the sides of a polygon must be line segments. They can't be curves like semicircles or something. So it turns out, in layman's terms, it's an enclosed figure where the sides are line segments. Okay, so we could start, the smallest number of sides on a polygon is the triangle. We could call it a 3-gon. We're going to be looking at the 4-gon, which is a quadrilateral. You have the 5-gon, which is a pentagon, 6-gon, which is a hexagon, 7-gon, septagon, etc., etc. Like an 8-gon is an octagon, like a stop sign. Okay, so we're going to start with the trapezoid. So this here represents the general case of quadrilaterals, and below this, all these things below meet the qualifications of a quadrilateral. Namely, they have 4 sides, but then they have some additional characteristics that make them special and unique. So we'll start with the trapezoid. What makes it unique is it is a quadrilateral, but it has one pair of opposite sides that are parallel. So remember, parallel is like railroad tracks, okay? We use arrows to represent parallel or double arrows. So if these segments were extended forever, these two segments would never intersect themselves. That's what parallel means. So in a trapezoid, we have all kinds of trapezoids. There's a particular type of trapezoid we're interested in often. It's the isosceles trapezoid, in that here, not only here's a pair of opposite sides that are parallel, but you have these two sections here, if you put them together, would form an isosceles triangle. So these two segments here are congruent, and these base angles here are the same measure, or they are congruent. So then, the way I'm doing my hierarchy chart, a parallelogram actually is a subcategory of a trapezoid, because it has a pair of opposite sides that are parallel, making it a trapezoid, but in addition it has a second set of opposite sides that are parallel. Okay, so all parallelograms are trapezoids, but not all trapezoids are parallelograms. So then below the parallelogram, we have the rectangle. So a rectangle, turns out, while it's not a defining characteristic, in fact has two pairs of opposite sides that are parallel. So these two sides turn out to be parallel, and these two sides turn out to be parallel. So it's actually a parallelogram, but a rectangle is also a trapezoid because it has one pair of opposite sides that are parallel. Okay, so then jumping from the parallelogram this way, we have the rhombus. Okay, a rhombus by definition has simply four equal sides, but it turns out that opposite sides, you have two pairs of opposite sides that are parallel. So these two sides would be parallel, these two sides are parallel, so all rhombuses are parallelograms. But that also means all rhombuses are trapezoids because they have one pair of opposite sides that are parallel. Okay? And finally, below the rectangle and rhombus, you have the square. So a square is a rhombus because it has four equal sides, and it's a rectangle because it has four right angles and opposite sides are congruent. But also turns out that in a square, opposite sides are parallel as well. So a square, starting from the top, is a trapezoid because it has one pair of sides that are parallel, opposite sides that are parallel. It's a parallelogram because it has two pairs of opposite sides that are parallel. It's a rectangle because it has four right angles and opposite sides are congruent. And it's a rhombus because it has four equal or four congruent sides. Again, congruent, I'm using that term a lot. You can think of it means same shape and size. In the case of right now, we're dealing with line segment lengths or angles. So finally, let's go to come back up here from the split on the foregon or quadrilateral. We went with the trapezoid. We talked all about that. Now we're going to talk about a kite. So a kite is like a kite that you think, traditional kite that you fly, but the defining characteristic is, again, you have two pairs of consecutive sides that are congruent. So here's two consecutive sides. They meet at that vertex. These two consecutive sides are congruent. Then down here, you have another pair of consecutive sides that meet at this vertex here that are congruent. Well, notice that a rhombus meets the definition of kite because, for example, here's two consecutive sides that are congruent, and over here there's another pair of consecutive sides that are congruent. So all rhombuses are kites. It's a special case of the kite because you don't just have you have two pairs of consecutive sides that are congruent, but you also have, actually you have four pairs of consecutive sides that are congruent because you have another pair here and here. So this concludes the video, but let's say one more thing. So actually notice this leads to the rhombus, which leads to the square. Well, a square is by definition a kite also you don't usually think of it that way, but notice here's a pair of consecutive sides that are congruent, and here's another pair of consecutive sides that are congruent, and yet here's yet another one. So it meets the minimum definition of the kite, because a kite simply has two pairs of consecutive sides that are congruent, while a square, like a rhombus, has four sides. Four pairs of consecutive sides are congruent. So this concludes the video, and I tried to explain how the hierarchy chart is organized for quadrilaterals. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. And you may share the content of this video with others, despite what I said in my opening remarks. Thank you. Have a good day.